That's right. Answer key time. All right. We have a simple coordinate proof. How do you know that? Well, because it's kind of laid out for you with coordinates. You don't have to do it that way, but that's a pretty good hint to get started. To do any of these, it's really helpful to know exactly what these words are saying, okay? So know your vocab. A mid-segment, you don't have to know that because I tell you that it's the thing connecting the midpoints of KL and MN is parallel. The mid-segment that goes from the midpoint here to the midpoint there is going to be parallel to the base, and it will be the average of these two lengths, LM and KN. Okay, so start off by doing the first bit where it says fill in the blanks with the coordinates for the remaining two vertices. That's actually not correct. It should be 3 vertices because this is now 0, 0. That's kind of obvious. But notice this is over 2A and up 2B to get to there. That up 2B is going to be what this is right here. The famous Shakespeare answer, 2B. This one is not 2B. This is 2C going over 2C because you're going over the same amount here as you went over here to get to this spot. These are going to be in line just like the 2B is in line right there. So really think through what it means when you're going in Cartesian coordinates, going over to the right and then up vertically. All right, once you've labeled those, now go back to this proof. This is the midpoint right here, and that has coordinates then that are going to be A, comma, B. How do I know that? Because a mid-segment, or a midpoint, is an average of these two x's. 2A plus 0 cut in half is just A. 2B plus 0 cut in half is B. Same thing here, except if I add 2C and 2C, I get 4C, and I cut that in half, it's 2C. Well, that makes sense because I'm going over 2C. How much am I going up? Halfway from 0 to 2B is 1B, all right? Why do I need those? Because I'm trying to prove that this is parallel. Things in coordinate proofs are parallel if they have the same slope. So what is the slope here? Is going to be the change in y. That's 0 minus 0 over the change in x. 2c minus 0. That equals 0. So that has a slope of 0. What's the slope right here? It's going to be b minus b over 2c minus a, which is 0. It's also 0 because 0 over anything is 0. So because the slopes are the same, those lines are parallel. All right. You could put it in the chart here. This is optional. You can also just write in a paragraph. But the idea is, I guess I can write it here. Because the slope of Kn equals 0, and the slope of this is let's see, we can call it PQ. They are parallel, all right? That's like how we do things in coordinate proof. If the slopes are the same, the lines are parallel. I want to prove that they're the average, okay? So the length of PQ is, well, how long is this length right here? Well, it's going to be that entire length all the way out to there minus this small bit. That's all the x values. So I'm going to have the 2c is the distance all the way out there in my x direction, and then I'm going to take away this amount, which is a. So that's 2c minus a. Well, what's the average? The average of LM plus KN is, well, this entire length here is 2C. That's the KN part, so I'll put that second. The LM is going to be going out 2C, but then taking away 2A. So it's going to be 2C going out, taking away the 2A like that. Well, that's the length of the two of them, but then divided by 2. Take away 2's from that, and it's going to be equal to C minus A plus C, which equals 2C minus A. So these are the same. Whoops, I'm way off the page. I'm so sorry. That's me doing the math there. The average of KL or LM and KN is, that's the LM part, and that's the KN part. When I do the math and I divide it by 2, I take and divide each by 2. There it is. I combine my C's. I could have added this 2C plus 2C to make 4C. When I cut it in half, I get 2C, and which is equal to PQ. Okay, so I've proven, I won't write it all out, but that is what I wanted to prove up here, that it's parallel and half the, and equal to the average of those two lengths. All right, so this one over here, again, know the terminology, know what scaling means. All three sides are different. I'm going to try to prove that it's impossible for such a triangle, scaling triangle ABC, to have a median. Right there's the median. A median goes so that these two parts are equal, cuts it exactly in half, but that's also perpendicular. All right, prove that that's impossible. There's something wrong with the drawing where this and this are different, but this is all true. Okay, so step number 1, I'm not going to recopy it down. Step number 2 is assume it is possible for a median, perpendicular median, I should say, median to be perpendicular in a scaling triangle. Suppose that is true. Okay, what would happen if this is a true drawing? Well, let's work it out. Step 3, I'm going to use this template here, okay? I got my givens. I'm not going to repeat that, all right? But I'm going to see if I can see that drawing up there. What I'm trying to show is that, well, if this is congruent to itself, 1, 2, 3, 4, if this is congruent to itself, and these two right angles are congruent to each other, and these two sides are congruent from the median, well, then these two triangles have to be congruent because of side, angle, side. But that's a problem. That's a contradiction because CPCTC would say that these are equal, but that's contradicting the previously known givens. So I would just write that out. I would say BM is congruent to MB. That's reflexive. I would say that AM is congruent to MC. That's definition of median. And then I'd say that I would maybe call angle 1 and angle 2 just to make it faster. I like that. Angle 1 is congruent to angle 2. And then again, I'm just saving time because perpendicular angles are each 90 degrees and congruent. All right. And then the triangles. Triangle ABM is congruent to triangle CBM because of side, angle, side. And AB then is going to be congruent to BC because of CPCTC, but that's a contradiction. So you got to show specifically. You can't just say, if this splits it down the middle, it won't work. That's just not specific enough. Try to be specific about what is it based on the rules that we accept in class There you go. It'll follow pretty clearly if you get that set up right. And once you have a contradiction, you can say, therefore, the assumption is false. Therefore, it is impossible. And again, I won't write the whole thing because we're about out of time. Thanks very much.